I'm gonna talk mainly about the differences between Lua and LuaJIT and how the speed plays into that. I am by no means a specialist on this topic. I knew a lot about Lua and not so much about LuaJIT, so this talk was sort of a talk-oriented learning process. I learned a lot while preparing this, basically by poking other people who knew more than me, and it worked quite well, so I really recommend this methodology. But yeah, speaking a little bit about me first. Hi, I am Etienne. I'm from Brazil. I work here at LuaJIT. Also, huge thanks to them for providing the space, the food, and all the support and resources. I don't use Lua here. I use Lua more on side projects when I want to develop things on my free time. I do have a lot of contact with the Lua community, so I have participated in Google Summer of Code and the LabLua institution twice, once as a student and then again as a mentor. And I organize LuaConf in Rio. So, okay, I realize some of you haven't used Lua before, and some of you already use Lua. So I was planning to sort of skip the introduction of this talk, because when I presented this talk before a PolyConf, and there it was, well, not a Lua focus conference, of course. So I took the time to talk about Lua in more details, explain what it was. And since here it's a Lua meetup, I was not really planning to go through that. But since I learned that some people here didn't use Lua before, I will go through this very quickly. So those of you who already know it, just bear with it. But to keep things simply, as you know, Lua is very small, and it's very known for being very small. So the whole distribution with the documentation and everything is under 200K. So it's used a lot embedded, both as in the sense of being embedded as a library into bigger programs, but also embedded as in in embedded system and very tiny microcontrollers. It is a very simple language, so the size of the code and everything reflects on the simplicity of the language and vice versa. So you can have it all on your head. It's very different from things like PHP, where if you just look for functions that begin with A, you will find over 400. And every time I look it up, the number changes. Every time I talk about this, I have to go back on the PHP documentation and just and change this number. So yeah, the whole Lua API can fit in one slide, and it's also very powerful. So the thing is, with this even though it's a very simple language, it provides all the mechanisms you need to build more complex things. So for example, Lua does not offer object orientation out of the box, but it does provide things like meta tables, which is a way of modifying the behavior of tables, which is the main data structure, which is sort of associative array of anything to anything except for nil. And we also have the lexical scoping and first class functions, and with all these very minimalist features, you can then have object orientation in the end. So the core of the language does not need to have everything implemented. So you could say that the core, the standard libraries where modules go to die, right? So Python, for example, the HCP module of the main Python library is not really used, so people use like things they grab from the package manager. So in the end, you could argue if it's really necessary that it is in the standard library. Of course, you can argue that then it could be complicated to figure out which library is the best one and how do I choose from the package manager what I want. This is another discussion. And Lua is, of course, known for being very fast. It has quite a reputation in this aspect. And I think this is also a reflex of its simplicity, of course. I don't think you would be able to make it so fast if it was way more complex. But just so you get an idea, I will apologize for this very crappy slides. So this is supposed to be like a benchmark of Lua versus Python, where Lua performs twice as faster. So, so this arose from sort of like my frustration with some of the benchmarks that were being done around. So as you can see, I did not do a great job, but my point is that benchmark is a very complicated process, as in like not always people are comparing the right things with the right things. They will sort of compare apple and oranges. So for example, you have like I don't know, in benchmark games, you have like comparing Lua with Java. And they're like, those are languages from completely different families of programming languages. So it doesn't really make any sense unless you're using Java as sort of like a baseline. And then you have like Java as a baseline and then two dynamic languages compared with Java, which was not the case. Or you find things like comparisons of Julia and Lua, which again doesn't make any sense because Julia is a just-in-time compile language and Lua is interpreted. So of course that Julia is going to perform better. There is absolutely zero sense in making those comparisons unless we're comparing Julia with LuaJIT, for example. Then you are comparing technologies which have the same purpose, and then benchmarking then and picking the one which is faster for whatever is the reason makes more sense. So if I'm going to compare Lua with like vanilla Lua with something else, I would compare it with Python, Ruby, not with JavaScript, because VH is also just-in-time compiled. So it's again in a different family of things. So when I start talking about benchmarking and speed, I'm no longer talking about the language itself and the characteristics of the language. I'm talking about the implementation of the language, and there can be many implementations for one same language. So you can have different interpreters that will follow like the same grammar and parse the same thing, but then how it behaves and below that, then it can differ a lot. So this is sort of the difference between Lua and LuaJIT. And there are many other implementations and alternatives. And so I think the thing that shocks the most about this slide is that I didn't put LuaJIT as a different implementation of Lua, but rather as a different flavor. So I'm going into more details about that later. So I'll just go through this list very quickly. So what I considered a different implementation of Lua is something that aims to be Lua and to follow the Lua manual, even if it really doesn't now, even if there are bugs. So I was not too strict about them. Maybe I'm being too strict with LuaJIT in this sense, but Well, my reason for that is that LuaJIT is very relevant. So if there are incompatibilities over there, it is way more critical than the other ones. So yeah, in terms of other implementations, there are LLVM Lua, Fast Lua, Lua, which is like Lua in Erlang. There is Starlight, which is Paul's project of Lua implemented in JavaScript. I'm trying to remember what is from. Oh yeah, Ramblin is like Lua in the JVM. And Lua Vermelha is a project using Eclipse OMR, which aims to do little modifications into the Lua interpreter and plug into this other thing and have like a faster interpreter with just-in-time things. I don't quite remember exactly. In terms of flavors, well, LuaJIT is sort of the start, and I'll talk about it soon. Well, we have Ravi, which is also just-in-time compiled and has optional type annotations and some other differences. There is TypedLua, which was the PhD project of Andrea from LabLua. I'm not currently, I'm not positive or like the current status of the project, how it's being used and what is the tooling around it. And MetaLua, which is, I don't think there's much going on with MetaLua, to be honest. I think it's kind of fading out, but again, I'm not sure. In terms of different languages, I think the most famous of those is Moonscript, which is a language that compiles to Lua like CoffeeScript compiles to JavaScript. So it has like semantic indentation, it has arrows stuff, some functional construct, some table constructor, different ways of doing loops. So it's a completely different language, and it compiles to Lua. Cell is a language implemented in Lua, which is a reactive language. Terra is sort of a Lua-like low-level language, so we have like much of the syntax is very similar, but like the purpose is a bit different. And Squirrel is another dynamic language, which is not implemented in Lua, but it is inspired by Lua. So it uses, it adopts many of the same philosophies. Yeah, so as I was saying, my focus tonight is to talk about LuaJIT and why I consider it to be a different flavor of Lua rather than a different implementation. So going through it very quickly. So what is LuaJIT? So it's a just-in-time compiler for Lua. So instead of just interpreting the code, it will do like the real-time compilation and then transform it into bytecode and I execute it then. And was developed by Mike Paul since 2005. It is way more complex than Lua in terms of the source code. So Lua is roughly 20,000 lines of standard C, and LuaJIT has way more than that, and much of it is like this customized assembly. So it's not really trivial to make modifications to LuaJIT. I wouldn't say that it's trivial to do it with Lua either if you're just starting and like modifying a programming language and learning how interpreters work. But I would not recommend LuaJIT as like an entry point to figuring out how interpreters work. I think that for this purpose, Lua is an excellent use. Lua is recommended very well for just like being a very clear and concise code base in C, and so it's very good for learning C and learning how an interpreter works. LuaJIT is also extremely fast, so not only because of the just-in-time compilations, but it does some very heavy optimizations in some areas. So even if you don't have the just-in-time compilation turned on, so you can use the LuaJIT just as a normal interpreter, it's already in average faster than vanilla Lua. It is still portable. In general, in terms of programming languages, the star is because it's not as portable as vanilla Lua. So pure Lua is way more portable because it can run on anything that runs standard C. So it'll run, I don't know, on a washing machine. And on LuaJIT, it might not exactly be the case because since it is a compiler and not an interpreter, it has to consider like different architectures. And then it will depend like which architectures are already implemented. So it already has like a wide range of architectures, so it is very portable, but it still doesn't beat pure Lua. And so going on, and like Lua, it's also MIT licensed, so it's one of the most permissive free software licenses, so you can fork it and rename it to Potato if you want, so there is no problem in that. But yeah, so like I said, I'm gonna focus a little bit on the speed. So again, sorry about very uninformative slide. Yeah, just to give more details about that. So this is like the average of different benchmark algorithms, so like Funkus Redux, Mandelbrot, you know, like the most common benchmark things, and I compared them with C as a baseline, and then I got like the average of each one of these implementations against C. So as you can see, like LuaJIT is in average. Of course, that for some specific cases, there might be a situation where VH will run faster than LuaJIT, or I don't think there is such a case for PyPy. But in average, LuaJIT was roughly twice as faster than JavaScript VH and 4 times faster than PyPy. So it makes me start questioning, so what is the importance of speed actually? Because I come to the conclusion that if speed is that important, then people wouldn't be using Python, and Python is a very widely accepted language. And as you can see, even the optimized versions of Python, so even like the just-in-time implementations of Python, they are almost roughly as fast as vanilla Lua, and cannot really be compared to LuaJIT. So these were like my personal benchmarks that I ran on this very laptop. But my results were also in accordance to like very well-known research. The reason why I decided to run it by myself was because, for example, this research does not mention JavaScript VH. And I'm like, well, JavaScript VH is very used, so I think this is missing something. So I would like to know how this compares to JavaScript as well. And then I will go to some other benchmark, and there will be like something else missing, and so or like some very important benchmark test that wasn't being run, or there was like a problem in the benchmarks, such as the algorithm for one language has a memory leak, and then I mean, the comparison then doesn't, it's not fair anymore. So this is a very nice research by Lawrence Tratt and Carl Friedrich Baltz. So it talks specifically about just-in-time implementations. And yes, it comes to the same conclusion that LuaJIT is one of the fastest just-in-time implementations you'll find, and even just Lua, pure Lua is faster than most of the other dynamic languages that are not JITed. So what are the differences from Lua besides the speed? I mean, if I have Lua and I have LuaJIT, and LuaJIT is faster, why would I use Lua instead of LuaJIT, right? There are some very strong differences, actually. So the main one is FFI, just foreign function interface, with the ability to call code from another language in Lua. So the difference between this and pure Lua is that, like in vanilla Lua, there isn't an FFI library. So this is done through the C API library. So you have to write the wrappers around the C code or whatever code that you want to call. And so it's less straightforward than FFI. So FFI, it's I could say it's way easier to use. So a lot of people prefer to use LuaJIT instead of Lua because of that. So if I say that speed is the only reason, then I will be lying. So there is also this. The problem with this is that by having an FFI, LuaJIT sort of like diverges a lot from pure Lua, because you can't have FFI in vanilla Lua. It can't be implemented in standard C, so it would break its portability philosophy of being written in standard C. And although there are like external libraries, so suppose you are running your Lua code on somewhere else that does not have a problem with running things that are not standard C. You could use the FFI library like an external model like that you get from LuaRocks on pure Lua, but it's slower than the C API. And from LuaJIT, using the C API is slower than using FFI. So you can't really write, if you're focusing on speed, you can't really write something that will be ideal for both situations. You kind of have to pick one. And then you can't write cross-compatible code anymore. Going on, the Lua compatibility on LuaJIT is locked sort of in Lua 5.1. So main Lua is now in the version 5.3, and LuaJIT is like 5.1 with some hints of 5.2, with some sprinkles of 5.3, and it's not really consistent. So I got this from Hisham's presentation on Lua application programming at the last LuaConf. So there's like this nice table about things that are present in Lua 5.1, Lua 5.2, 5.3, and LuaJIT 2 and 1. And as you can see, like it's not really consistent, so you can't really know why some things are there and some aren't. At least I don't know. It could be like through popular demands, like Lua 5.2 now has this other thing, and could we please have that on LuaJIT? So there's like a popular demand to have this, or just because someone's decided to make a pull request implementing this one thing and it got accepted. I don't know, but in the end, it's not consistent. So for example, one of the main differences for me is setemp and getemp. They work very differently. Table unpack as well, which is still sort of in the old way at 5.1. I don't think that these differences are the major differences, but it still causes a problem, because since LuaJIT is very widely used in many companies, and it has like this divergence on the mapping to the versions of vanilla Lua, people when they try to write code that is like cross-compatible, they will end up writing code that is Lua 5.1 and ignoring Lua 5.2 and Lua 5.3 completely. So what we have nowadays is that lots of things are written in Lua 5.1 to be able to use, to be able to run both in the vanilla Lua interpreter and in LuaJIT. Lua 5.2 is basically that. And then Lua 5.3, which is the newest version of Lua for people that are using pure Lua, then it has a wide adoption. So we have like this 5.1 and 5.3 basically running together, when the ideal case would be that the use of Lua 5.1 went down, and then the 5.2 went up, and then the 5.3 went up, and this natural development does not happen because of this attempt to write things that will run on LuaJIT as well. Another difference I would like to stress is that when you really start refining your code for speed and to take advantage of the just-in-time compilation, the code stops looking like idiomatic Lua, because so everything that is in the Lua language is implemented in LuaJIT, but not everything was optimized to use the just-in-time compilation. So some things are still interpreted, and some things will be just-in-time compiled. So if you have a situation where something is in there, but it's not just-in-time compiled, you'll prefer to use something else, something that would maybe not be the natural way of writing Lua. So I think that the easiest example I can think about is the pairs function, which is like just like an iteration in a table. And no one would ever think this is a problem to use in Lua. I mean, why don't we use the pairs function? And then you look at LuaJIT code or code written to like profit heavily of LuaJIT, and then you see like iterations done in different ways, and you question yourself why. And then so in normal Lua, that wouldn't the difference wouldn't be major, and in LuaJIT the difference is between being interpreted and just-in-time compiled. So it could be a considerable difference, especially if it's like inside a very tight loop. Another difference, I won't go into details about this now, because the next talk is basically about this topic and specific. So Pete, if I say something now that it's like, I'm gonna talk about this, just shh, you can shh me. Or also if I say something that is wrong, also like jump in and save me. But yeah, the LuaJIT also has some bugs that are not present in the main Lua distribution, and I think the most known of these bugs is the memory limit. So the memory limit is basically that you can't really allocate data structures bigger than, I think it's 2 gigabytes. In LuaJIT, you can sort of work around that if you do the allocation with malloc on C through the FFI, because then it doesn't count in the LuaJIT states and pointers management. So the reason behind this is sort of a heavy optimization of LuaJIT. So to save a lot of footprint, the typing system of LuaJIT is done using non-tagging. So what happens is that because of IE specifications, everything that has a certain exponent, I think it's like all ones, is considered not a number, but only one of those is actually passed around to represent not a number underneath in the compiler and the interpreter. And so you can sort of have all these other not a numbers that you could use for something else. So this is what the typing system uses different, so you can allocate parts of the mantissa for representing the types, and then the rest you can use for anything else. So the pointer of your object, for example. And then you can pass everything around as simple doubles instead of complex data structure that will like signalize what type is this object. So you save a lot of footprint, but then you have a restricted space for the memory pointers. And this is why there is this limitation. So there is a fix to that in the newest version of LuaJIT, which was contributed by Pete. It is currently available as a flag, so you need to compile LuaJIT with this specific flag for this fix to be available. Another difference, there are some small oddities, so they're just like things that I don't particularly like. So, for example, LuaJIT has this 64-bit FFI integers. They are notated as like LL or ULL for unsigned, and it's a weird mix of a number and a C data. And then the problem is that it's declared like a number, it looks like a number, but it sort of behaves like a constructor. And because this is blocked, you fall into situations like this. So this wouldn't happen if you just choose like a normal number, but when you use this magical number, then you have these problems. And I don't like that. I mean, this is the sort of thing, if you know how it works, you just avoid it, but it just doesn't make a lot of sense to me. I just think it's ugly. Another difference is the bytecode. So the bytecode that LuaJIT generates, it's different than pure Lua, and it's also way more complex. It has like way more instructions. And a very important difference, which is not a technical difference, but I also think that's important to mention, is the governance of the project. So Lua itself is kept by a research laboratory at a university. They have their problems, their specific problems that are related to the structure that they maintain, but it sort of looks more stable to me than the governance of LuaJIT, because the LuaJIT was sort of a one-man project by Mike Paul, and there are many contributors who understand the the code of LuaJIT and try and participate and make contributions, but he is a person that is free to do whatever he wants with his time, and of course, and he was sort of like kind of abandoning LuaJIT, but not really. So he was moving on to other projects, but still being there as sort of like the father figure and like maintaining the project and going through the pull requests. And I think that his knowledge is invaluable, but I think that this sort of limbo states between leaving and not leaving could sometimes be more detrimental than beneficial, because then it makes it difficult for other people to step up and have like a better leadership. In terms of performance tricks, so I talked a lot about speed, I talked about LuaJIT and the just-in-time compiler and how people take advantage of that, but I didn't really say how. So, well, most common rule about performance optimization is not doing it unless you really know what you're doing, and use a profiler so you know what you need to improve. But yes, if you really need more performance, then you can follow the normal Lua tricks for performance. They will also work on LuaJIT. So caching global variables on local variables, because the access to, this is a very known trick, and so the access to local variables is faster than to global variables, and this is the reason why when you look at a Lua code base, very commonly you see like the standard library functions being assigned to a local variable. I don't think this is like makes a huge difference, but well, it's there. Normal things that would work on pretty much any language, any similar language, which is like not concatenating strings in a loop, because then it will generate a new string on every iteration, and you don't really need to do that. You can just like concatenate everything in the ends. For LuaJIT, like I was mentioning before, not everything of Lua that is in LuaJIT is optimized in the just-in-time compilation. Some things are still interpreted, and so there is a list for that. It's in the wiki. It's the not yet implemented. So if you go through there, it's basically a list of everything you want to avoid if you are really neurotic about performance. Again, use the FFI instead of the CAPI, because it's faster in LuaJIT. Again, sorry, this is a case that is contrary if you're using vanilla Lua and if you're using like the external library, just reminding. And avoid nested loops, but like inside a tight loop. So because then like the tracing, I don't really understand how this works, so sorry if I'm saying some bullshit. Like the tracing of the just-in-time compiler will have more difficulties in optimizing it. And most of these are really only important if you have like a tight loop. Otherwise, I don't think that the difference is very considerable. So my conclusion is that both of them have their differences and their advantages and their problems. So from my experience, and if someone asks me what I would recommend, is just use pure Lua if you want something that is fast, simple, and very good, and use LuaJIT if you really need the performance or I didn't mention this, or if you really want to use the FFI. And you're willing to accept some of its differences from main Lua, and you're not willing to use compiled language straight away. And just remember that there are these differences, and tackle your code accordingly. Yes, this is it. If you want to know more about this, it's very easy to reach the Lua community. It may seem like it's a small community, and it is, but it's a very approachable one. So we have, I am not in all of these channels, so I'm usually not on IRC, but yes, so there's the mailing list, the Twitter accounts, I'm on the Telegram group. There's a bunch of people in the Telegram group, it's growing, so if you want to just chat with other folks in a synchronous way and you don't really use IRC, there's this. And yeah, this is it. I just want to make a quick appeal before I finish, just like a shameless plug. So this is a project of mine that is abandoned, and I'm really ashamed about that. But yeah, if you have the time to help, or if you want to take over, or if you have any opinions about using Lua for the web, and you want to, you know, check this out, please talk to me. And yeah, thank you. Any more questions? Wait, a hand was raised over there. Or
I thought if there was no question, I just sort of this fellow gentleman pointed out why there are not enough Lua users, there are more JavaScript developers. I think there are two things here. What I think just developers are lazy. They're tired with things. They don't want to try something new. Not everybody's like it. Some people try, and there are people who are coming up. It is growing, but it's not growing like JavaScript, because let's think about it. You know, browser started JavaScript. Everybody was using that language. So technically there is a reason for that. But I think going forward, there are more people joining that community. There are people who know there's more powerful language on the server side. So, I think, yeah, it's just growing community. It will take some time, but it's a concern. I appreciate what you have, but it's not disaster, because it's growing community. A lot of the new companies I know are using, so it's just slow.
maybe not this slow. I was checking the users on Lua August website, and there is actually a quite nice exponential curve that like it grew a lot very recently, and it's quite nice to see. So maybe it's not as slow.
Sure. Okay. Fair enough. Yeah. So, but the point is, if you compare with JavaScript,
Oh yeah, there's.
But that's just the way it is. I don't think that's a real concern.
Yeah, there is really no way to compare with JavaScript. Like when you go on the browser, it's basically like the only option. You have to go through JavaScript, and you just have to accept it. It might change with WebAssembly, but I don't know what's gonna be the outcome with that. I mean, the state of existing JavaScript libraries is,
sure,
it's already there. So it is complicated, and I think it's kind of sad if you think about some other areas like machine learning, for example. I was really hoping that Lua would just like be the star of machine learning because of Torch, and Torch is really great. But then there is TensorFlow, and Google bought this company. They used to use Lua before, and then after they bought it, Google made it use TensorFlow from now on, and it's just like makes me cry inside. And it's very complicated. It has a lot of politics. It has lots of coincidences. It's really hard to like point a finger at one thing.
So I think, to wrap it up, I think what you guys are doing, everybody, all of us are doing, is exactly right. Sailor, projects like this, create new things in it. Even I'm planning a few things. Just create more things, open source, in Lua, so we can grow this.
Do you have any more information on Lua? Because that sounds quite interesting.
I don't, but I can check it out with some people and like redirect it to
Yeah, I'm sure I can. Wait here or not.
I
I know how to do a web search.
but I can poke some people who know more about this and direct you towards them. Maybe they will be able to tell you more about it. Sorry, I have never used it, so I don't know much. Any other questions? I think we are out of time. So I think it's better if you just have a break.